My name is Troy Daniels. I'm the head of technical training here at SimpliPhi Power. Today, really, we're going to dive into environmental considerations regarding the batteries. So that could be anything from temperature, humidity, altitude, some of the big questions we get around those, and kind of, some mitigation tactics, as well as just the limits and understanding the battery and how it responds to these various different things. Q&A at the top. If you have any questions, just go ahead and use that control bar, type into the Q&A. We should have some time at the end. We can go through some questions. So if you have anything, just throw it in there. All right, let's get started. So we're going to start with temperature considerations. I think this is probably the most common as far as something that affects a lot of people when installing batteries, both residential and commercial, is looking at temperature restrictions. If you're up north in some of the northern areas, oftentimes you really need to kind of keep this in mind. And it's kind of number one on the mind when it comes to where to install. So as far as our specifications go on the batteries, operating temp, -4 Fahrenheit to 140 degrees Fahrenheit, and charging temperature of 32 degrees Fahrenheit to 120 degrees Fahrenheit. So basically, it's something to consider here is operating versus charging. And actually, before I go on, just for anyone that's working in Celsius, the charging temperature is 0 degrees Celsius to 49 degrees Celsius. So basically, the difference between operating and charging, operating being the battery's either in a discharge or that it might be in a standby mode. So that's operating. So for the most part, we typically need to consider charging temperature as the more important of the two. And that's our kind of window we want to sit between 32 degrees Fahrenheit and 120. Storage temperature is a little different. We rate that differently. So if it's stored, basically, if this could be a huge benefit if you maybe are only storing it, or maybe you're only using the residence during certain months, maybe warm months. Oftentimes I see this with people with cabins where they have battery storage. It's a great way to store the batteries, even though the temperatures are going to get lower than you typically would want for charging and operating. The storage temperatures, 6 months. So that meaning if you're going to store the batteries for 6 months, 14 degrees Fahrenheit to 77 degrees Fahrenheit. So -10 degrees Celsius to 25 degrees Celsius. 3 months, -4 degrees Fahrenheit to 113 degrees Fahrenheit. So -20 C to 45 C. So as you can kind of see there, it more relates to cold temperatures than hot temperatures. So really, again, if this is a great way to save the batteries and use them in applications where maybe you are only using the system in the warmest months and storing the system in the cold months, even in that cold location. So a little bit about the product line and the differences here. Really, I'll just go through kind of the two main differences between our main products here. The Phi product line does not have any internal temperature control through the battery management system. The temperature ranges are the same as the other product lines. However, temperature control is up to the customer and the installer. There's no built-in protection there. It does not have that regulation. It does not sense when it's too low, meaning if you try to charge this battery at 0 degrees Fahrenheit, it will accept a charge and it could cause damage. So this one does not have that kind of built-in intelligence in the battery management system. Not a huge deal for most people if you're in an area where it's not going to be that cold, or if the area where the actual installation is stays pretty warm, it shouldn't be a problem. The SimpliPhi, this is our comms-based battery. This battery does have a little bit more of an intelligent design put into it with the temperature control functions. So the SimpliPhi battery does offer temperature control. The temperature ranges, both charging and operating, are the same as the standard Phi. However, basically what this allows for is you to kind of have a safeguard against charging when the temperature is too low or too high. It won't heat or cool the battery more than any other battery would. It just simply says, hey, if the temperature goes to this temperature, either ramp down charging or make sure the charging does not happen. The interesting part about the SimpliPhi and this kind of feature is actually really important to note is that this feature actually works off operating and charging temperature. So since the operating is actually allowed to go a little bit lower, this BMS actually knows when you're discharging. It'll allow you to discharge lower. And if the charger tries to turn on, only then will it disconnect. So you can get a little more juice out of the battery, even if it's pretty cold, as long as you're not charging. But again, that protection's built in so that if you do try to say, charge at negative 20 degrees Fahrenheit, let's say, it will disconnect the charger and make sure not to harm the battery until it's safe, until it hits that higher temperature. So it has that feature built into the battery internally. So when considering cold temperature, it is important to understand installation location and temperature at the location. Often an area or location, temperature is significantly lower than the actual installation site. That's kind of always, I see hiccups there where, customer just is simply going, hey, well, I know the temperature in my area gets to, let's say 20 degrees Fahrenheit. Well, you can still mitigate that as simple as, is it indoors? Is that indoor room maybe a little bit ice or a little bit insulated? That's probably enough to deal with that. Maybe let's say 10-degree gap that you might be worried about. So again, we don't need to just look at temperature outside. We really need to consider where is the battery going to be located and what will that temperature look like. We also should consider the battery's internal temperature. What I mean by this is the battery, to kind of go back here, we look at the battery as a whole. This is just the case of the battery. Within it are the cells. And between that is some level of insulation and some other electronics that do keep fairly warm. And the batteries themselves do run a little bit warm, not hot by any means, but they do run warm. So we can expect that the battery's internal temperature typically is going to be a little bit warmer than the outside temperature of that battery. So again, we think about maybe you're installing in, let's say, look at this shed here. I know these guys are actually up in Alaska. They do a ton of installations, 907 solar. Let's say that this is where the battery is located in this. Maybe it's insulated enough to up the temperature by 10, 20 degrees, plus the battery's internal temperature is a little bit warmer. They're probably doing okay, even during those colder days. Cold temperatures without design considerations can lead to kind of what are the damages caused here? What can happen when charging in cold temperatures, when discharging below the cold temperatures that we recommend? You can see a loss of capacity at temperatures below freezing, potential reduction of cycle life if charged at C/2. Again, the SimpliPhi kind of has this intelligence built in where it can actually ramp down charging even below that 0 to kind of allow for that a little bit of leeway there. Charging at the lower the charge rate and the lower the temperature, the less damage you can likely do. But if you're charging, let's say C/2 and you're way below the temperature restrictions, you could definitely and probably will hurt the battery. Further reduction in cycle life if charged at temperatures below 0 C. So this is really kind of the unfortunate thing that's going to happen if the guidelines aren't met. Okay, so external considerations with cold temperature. I think this is, again, we're talking about charge rate reduction can help to prolong the life when charging in low temperatures. The Phi battery does not automatically reduce charge rate based on temperature. Charge rate reduction can be used, dropping below 0 C still cause out of warranty damage, but we can see some of these kind of rough figures. So again, we don't ever recommend doing it, but I've seen people, if they're in a bind and they absolutely need to, this would be kind of the guidelines here. Looking at, 7 amps would be a good charge. We're talking a single 3.8 kilowatt hour battery here. So this is a 75 amp hour battery. We're talking about when we're in this kind of window, 7 amps, and then these windows 15 and 30. I think realistically, we've changed this so that it's more, this is both 30 now and more this matters here. But the SimpliPhi can actually do this on its own. So if it sees it go below or to 0, it can actually ramp down the charge rate before absolutely just disconnecting the charger. So it gives a little leeway. And again, if it's like, let's say we just hit that 0, we hit below 0, it'll try to reduce the charge rate, then it will disconnect if it still is getting lower. So that's a nice feature of the SimpliPhi. And it's a great battery when you have cold weather restrictions. This is a go-to of mine. I mean, it's the most simple method when looking at, how do we mitigate cold temperatures? Insulation is the easiest. And we have some suggestions for insulation that we would recommend specific for batteries, making sure, you're not ending up with an insulation that could be dangerous, that gets warm and maybe heats up and catches fire. I've seen people use some pretty bad insulation that's not approved. So I would always reach out to us first for recommendations. But the idea is the insulation should be on all exposed surfaces between the battery and the enclosed walls. And really, when in direct contact with the batteries, it can act to keep that heat in. It basically heat dissipation sink. And it's just really simple stuff here. And just the idea of, maybe you have an enclosure, it's outside, but you think your temperature is going to hit, let's say 0 degrees Celsius every now and again. You could just insulate lightly, and that's probably plenty to make sure that it's not going to go below that temperatures. If batteries are to be set on insulation, a rigid insulation capable of supporting the battery weight needs to be selected. So, here's some ideas of a rigid insulation, and that's always important when looking at, something that's going to be weight bearing. If other power electronics are present within the same enclosure, so for instance, our access unit, our all-in-one ESS, residual heat generation from those different components, like the inverter and the charge controller, will be trapped and contribute to increased temperatures. So basically, all these components put off a certain level of heat internally into that cabinet. So if you have it all you've got your inverter, your charger, and your batteries all put into a single cabinet, you oftentimes might see a little bit more heat than if it was just batteries alone. So that's something to keep in mind always. And definitely, if you're going to be adding insulation, you should keep that in mind too. Make sure you're not overdoing it if there's already heat coming off the system. I think the biggest hang up there might be if, let's say, you end up in a location where it's a lot of fluctuation. Maybe it's really hot in the summer months and really cold in the winter months. And there's that big kind of gap between the two. That's where you might need to consider this and make sure you're not overheating. Temporary insulation can be employed when temperatures drop below 15 degrees Celsius intermittently. The insulation can be added and removed as necessary from the enclosure. I mean, obviously that's, you can easily pull and put in some sort of insulation if it's something like this, or even like the rigid foam. Oftentimes we can kind of adjust that based on the time of the year. Probably the most asked about is, do you have heating pads? We do offer heating pads. I try to steer people clear of using a heating pad because it does use a lot of electricity. There's no way really around that. And I really think there's other methods, and really it comes down to installation site, the installation, and different features like that, or when you're using the battery. But if you absolutely need a heating pad option, it is there. So SimpliPhi provides options for installation in which direct heating source applies to the battery bank. So again, this is really to heat the battery. The batteries just sit right on here. This will heat up the battery, and it actually has a thermostat connected to it. So it knows the temperature, and it can actually measure the internal temperature of the battery. And based on these thermal readings, the heating pad will turn off and on to make sure the batteries stay within a specified window. These pads, though, they do add a lot of additional load and require AC power to be supplied via a relay from the inverter or directly from an AC source. So, design considerations should always be followed here. You're talking about a bigger electrical load. I don't have those specific figures right now on me, but it is significant enough. And definitely if you're talking like a 2 or 3 battery system, it's pretty significant if you have a lot of cold temperatures you're dealing with. So that's always something to consider when using these external heating pads is that they do use power, and it will be part of a load, or be a load in the system that needs calculations. Another little trick, this one definitely is something my colleague Matt Walker has talked about a lot and likes to use, is third-party devices. Basically, this comes down to chargers. So for instance, the Victron charger it used to be internal. I believe Matt was just telling me the other day that now it does require an external kind of thermostat device here. But basically, this feature within these kind of charge controllers, and using things like the Victron BMV Plus, they have the ability to basically act as that temperature sensor. And the same way the SimpliPhi would disconnect the charger, they will disconnect themselves with that preset temperature. So basically, not a lot of charge controllers do this, but there are some. Definitely the Victron's the one I know of the most. You can set that up, basically say, do not charge below this temperature, and it will sense the temperature off the battery and make sure that it is not charging below that temperature. That's kind of a built-in intelligence that you can add into a system where the SimpliPhi is not there. So this is kind of a nice substitute. It is important to consider most of these devices only consider ambient temperature. Do not factor in the battery's internal temperature, which may limit the battery's ability to charge, even when the temperature inside of the battery is not that low. So what I mean by that, if it's 10 degrees warmer in the battery, but the sensor is on the outside of the battery, it will stop charging before it's actually really needed to. So that is something to consider as well. All right, I've talked a lot about cold temperature. I really only have a little slide on hot temperature, and there's a reason for that. Hot temperatures are not as big of a deal when it comes to our batteries. The SimpliPhi battery actually can charge up to 120 degrees Fahrenheit. Obviously, there are definitely sites and applications where that will be a problem, but for the most part, it doesn't come down to be as large of a problem. Definitely not here in the United States, where we have that big of issues with it. So we have some units that actually were originally with the Department of Defense that were overseas in desert areas that held up fine at even higher temperatures, but we do recommend keeping it up below 120 degrees Fahrenheit. So really, again, some of these situations might come up, some desert applications, but it's pretty rare. Similar to cold weather, cooling systems connected to a thermostat can be utilized. It could be as simple as a fan or as advanced as an HVAC unit. Definitely like high voltage stuff, I see people utilize HVAC either way. And it is important, again, to note that the internal temperature may not be the same as the ambient temperature. That actually is funny because it actually plays the other way typically, meaning if it's really hot outside, probably the battery actually might be a little bit cooler on the inside. Definitely when it's operating, if it's charging, it might be a little bit warmer. Okay, let's jump into humidity. Humidity does come up a lot. We've got a lot of applications in areas even here in the States like Florida, but definitely, we've got a lot of installations down in Puerto Rico, a lot of the Caribbean, South America, and Africa. Some really humid places that will need that kind of consideration and understanding. So atmospheric moisture by itself does not pose significant threat to the batteries. So again, atmospheric moisture by itself does not pose significant threat to the batteries. Issues actually arise from two factors commonly present along with the humidity itself. That's condensation and salt spray. So liquid water itself is not good. If your room is so humid where the batteries are installed that it is dripping, there's actually liquid water present, that might cause an issue. That could cause damage within the battery. Maybe it leaks onto the battery and goes right into the battery. Maybe some condensation builds up around the edges of the battery. So that's where it becomes an issue. So we just kind of got to keep that in mind. Humidity itself is not a big impact. The liquid water itself would be. And then liquid water with salt. So salt spray. So again, if you're just living by the coast, we manufacture in California, maybe 5 minutes away from the beach, we're pretty close to the ocean there even. It's not about that as much as the actual liquid, the actual salt spray. So if that's going to happen direct to the battery, you might see some kind of promoted corrosion within the battery. It would be pretty rare that you would see a lot of that if you were, as long as you were installing indoors as you're supposed to, you really should not end up with that much or any salt spray. And as far as humidity goes, kind of same thing. You shouldn't expect that in the, let's say well-insulated area the battery's installed in. You really aren't going to see a lot of that liquid water drip. So again, that's why it should be kept out of condensing atmospheres. So hot or cold, salt air from the ocean or similar environments, and water in general. Looking at stuff like our NEMA 3R enclosures, that's if you're going to install outside. So actually this one right here, installation by Kenneth Trent, he has done a lot of access units I know of. So those are all-in-one ESS solutions in Florida and other areas that do see high humidity. So I know for a fact these have sat in that NEMA 3R enclosure and been okay in these high humidity areas, not seeing salt spray, not seeing that actual liquid water form. All right, on to altitude. Altitude comes up a lot. I actually just have a question in my inbox right now about altitude. I don't necessarily, I'm going to just start by saying we don't have a specific altitude limit. We've tested some higher altitudes and we can kind of look at the highest battery that's been installed. We do have some kind of testing altitude chambers and things like that we can use, but we really don't have a limit just yet. It tends to be colder at higher elevations and the air is less dense as the air pressure lowers. So for given temperature, air that is less dense has reduced heating and cooling potential. Low pressure poses a direct issue to pouch type cells as they lack a rigid housing. We do not use pouch type cells. We use cylindrical cells. So for that, we don't have to worry nearly as much. So prismatic and cylindrical cells, however, they don't have that issue against the pressure differential between the outside and the inside of the cells that are higher to the point that atmospheric pressure is essentially irrelevant. Altitude provides no direct operational limit for our battery. The equipment in which the batteries are attached may be different. So that could be an inverter, a charger. Definitely, like what I see a lot of the times is, low insulation in the air at higher altitudes. We don't want to have a lot of high voltage equipment. So 48 volt battery, 48 volt inverter, 48 volt charger is probably what I would stick with. If you have, large strings that are, pretty significant as far as voltage goes, you might see a little bit more chance of arc fault and some kind of dangerous conditions. You'll see a lot of batteries actually that are high voltage don't warranty for high altitude, but it's just not really a problem with our batteries. Oftentimes people will ask me for the what's your max altitude, and I kind of always come back with the same thing. What's the application you're talking about? What's the actual altitude you're looking at? And if it's a hypothetical, again, we just don't really have that data. But typically, if it's not a hypothetical, we can give you the green light, on the project based on the altitude you're giving us. Vibration. We're talking to mobile batteries. All of our batteries are rated for mobile applications. So our batteries have been trailered through the mountains terrain of Afghanistan with the Department of Defense. Their design basically was around that vibration because that was a lot of our original design with the battery. Compared to life in like an RV or a van, it's going to basically be nothing compared to what these batteries were designed and tested for. They're not necessarily tested to be vibration resistant standard, but we warranted them for mobile applications. If there's any issues related to that, we can always look, but we've got a ton of batteries mobile wise, and they are all warranted for that. Okay, I'm going to talk a little bit about testing before we wrap up. So again, for those that might have joined late, if you have any questions, just type it into the Q&A. We should We should have a little bit of time. We're about to be out of our 30-minute session, but I'll try to get through these last few slides and we'll just stick around and answer some questions. So as far as testing goes, SimpliPhi Power continues to develop and deploy both in-house and external testing. So we actually employ a number of lab-based tests that simulate different conditions the batteries are subject to. This can be everything from just normal conditions like using grid, using solar, temperature, altitude, charge and discharge. We can kind of simulate at our facility different real world expectations and then run that kind of those tests. You can actually see our picture here of our facility in Oxnard, one of two actually. We have two pretty close to each other, only like a block away. And we actually have a pretty large section just for test and validation at this point. So a lot of these tests we can do in-house. Additionally, we undergo numerous third-party testing with things like UL, Intertect, and really, these are both for NEC purposes and to make sure that we are always sticking with third party as well to kind of validate the claims that we're making in-house. So we do a lot of those testing as well. I'm going to talk through UL here in a second. So I'm going to skip over that because we have one slide and then we're going to go actually into all the UL testing. I'll go into the UN 38.3 first. So these conditions are not necessarily in spec, informative for safety reasons, but do not be performed on our batteries. So basically, that's just a little disclaimer, but what the UN 38.3 is, altitude stored at a very low pressure. So it simulates high altitude. And again, our batteries have been and passed through this. Thermal, cycling between 72 degrees Celsius and negative 40 degrees Celsius. So again, this doesn't mean that we can always operate the battery. This is just what we've had done. We've had vibration testing done as well there, 36 hours of intense vibration simulating transit and shock. So 18 impact simulating repeated drops or crashes. Basically, to pass this test, no leakage, no venting, no disassembly, no rupture, and no fire. Open circuit voltage of each battery directly after testing, not less than 90% of its voltage prior to each procedure. So we do have this test and we have passed. And I guess there's two more here that are called out. The external short circuit, battery heated to 57 degrees Celsius for 6 hours. Then terminals are short circuited until a maximum temperature is reached and then cool down occurs. It must not exceed 170 degrees Celsius and must not catch fire for that test. And the last one, overcharge, twice maximum charge current. So we allow for 37.5, they use twice that, and 1.25 times max charge voltage and must not catch fire. So again, this is not saying that you can do these things to the battery and it maintains its warranty. We've just gone through this testing to make sure safety really is above all with these batteries. As far as the UL specifications, we have UL 1642. This is a cell level testing specifically. So it just goes through things like shock, vibration, drop, heating, yada, 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 all of that stuff it goes through on a cell level. UL 1973, the very big standard for a very long time, relates to module level safety. So this is battery level. That is what we would consider the battery level itself. And then the most recent UL 9540, this relates to system level safety. This has been popping up all over the place. So you're going to see it more and more jurisdictions where they're looking for that UL 9540. We do have numerous products like our Access line that are approved for UL 9540. And that testing we have completed. On a kind of related note, we have UL 9540A testing done from UL Labs. Now, UL 9540A is different than UL 9540. I know it's kind of confusing. This is not a listing. This is a test protocol. I have a whole training coming up on that. We had to reschedule, but we do talk about our most recent results from the 9540A testing. Basically, this has a lot to do with fire safety. So basically a series of fire testings progressively getting larger are done on the batteries. our testing came out great. It actually allows us to kind of have looser guidelines on things like sprinkler systems and stuff like that when an AHJ is looking at the battery and looking at the 9540A test results of that specific ESS system or battery and making calls. So we've gone through that process as well. We've got tons of press release out if you're interested in hearing more about that 9540A testing. All right, very quick, just a quick plug for our program. If you've been installing our batteries already, join our IQ program. This is not a requirement to install our batteries, but if you're doing it, if you have an install under your belt, go ahead and sign up. You'll end up on our where to buy page. You'll end up getting a lot of marketing kind of acknowledgement. You'll end up with some swag and some other cool benefits that are coming this year that are pretty big. So I wouldn't miss out. It's super easy. You can just go to this link here and fill out the application. It takes about 10 minutes. All right. I see one question, so I'll answer that one. If there's any others, please, now's the time to type them in. I'm happy to answer anything. So solar modules have test sequences such as IEC 61701. Do the batteries have a similar standard? I'm not super familiar with that one, IEC 61701. So I can't really say for sure. I'm hoping that what I went through with the UL, the UN, those kind of testings is kind of the same thing we're looking at as far as kind of test sequences. All right, well, it looks like we have no more questions. I just want to say thanks everybody for hopping on. This will be live, this recording, if you ever need to refer back to it for any questions, or shoot me an email at training@simpliphipower.com if you think of any questions in the meantime. Thank you very much, everybody, and I hope you have a wonderful day.